Alright, 3.3, complete the square, page 112 through 115. In some quadratic equations, there exists a perfect trinomial square, which means two factors are identical. Something like the quantity of x plus 2 times the quantity of x plus 2, or quantity of x plus 2 squared. However, not every quadratic equation is a perfect square, and actually, it would most likely be a special case, so most of them are not going to be perfect trinomial squares. Alright, and this is where our method of completing the square is incorporated. And that is what we're going to mostly focus on in this entire unit. Alright, what am I talking about completing the square? Well, this is when you have something like x squared plus bx, alright, and I'm going to add the quantity of b divided by 2 squared to it to get a perfect trinomial square. Alright, so here's kind of the case. It may make some sense or not, but you have x squared plus bx. Well, if I take that bx and I cut it in half, I get b divided by 2x and b divided by 2x. And then if I add b divided by 2x squared, that creates that perfect square, perfect trinomial square. Alright, here we go. So x squared plus bx plus b divided by 2 squared equals the same thing as the quantity of x plus b divided by 2 times the quantity of x plus b divided by 2, which is also the quantity of x plus b divided by 2 squared. Alright, so I will walk you through these problems. I think it will make more sense as we do that. But nonetheless, concept number 1 has perfect trinomial squares. So I don't really have to do all that. There is a shortcut here involved. And what I mean by that perfect trinomial square is right here. So I have x squared minus 16x plus 64. Well, x is a perfect square. 64 is a perfect square. If I take the square root of x squared, I get x. I'm going to take that minus sign right there, the square root of 64, which is 8. And if I put that in parentheses, I take my two terms right there, x and negative 8, I multiply them together, and then double it. Do I equal the middle term, that b term, negative 16x? Yes. Alright, so then I can just put a power of 2 there. Equals 100. And next step is to solve by taking the square root. So I take the square root of both sides of the equation. That power 2, that radical are going to cancel each other out, giving me x minus 8 on the left-hand side. Oops. Equals positive and negative. The square root of 100 is 10. Add 8 to both sides of the equation. And now really, I kind of run out of room, but x equals 8 plus or minus 10. Alright, 8 plus 10 is 18. 8 minus 10 is negative 2. And voila, I have my answers right there. 18 and negative 2. Alright, go ahead and give number 2 a try. Pause right now. When you are done, unpause, and I'll be showing you the answer. Okay, number 2. You should have x equals negative 4 and negative 26. Concept number 2. Making a perfect trinomial square. Alright, so this time you have to find the value of c that makes x squared plus 14x plus c a perfect trinomial square. So to solve for c to make that perfect trinomial square. Then we're going to write the expression as a square of a binomial. Okay, so what I want to do is I'm going to take this 14, which is really my b term, right? So I take let me write this, b divided by 2 squared equals 14 divided by 2 squared, which is 7 squared, which is 49. So c equals 49. And to find c, it is, and I probably should have wrote that here, c equals b divided by 2 squared. Okay, now once I have that, I'm going to write my equation as ax squared plus bx plus c. So I have x squared plus 14x plus 49. And what I'm going to do is, again, I'm going to factor it to a binomial squared. So if I have a perfect square here and a perfect square here, I take the roots. Square root of x squared is x. Square root of 49 is 7. I take that sign right there, bring that one down. If I multiply them together, I get 7x, and then if I double it, do I get that middle term, 14x? Sure do. That means I did everything right. Alright. Go ahead and try the same thing for number 4. Now you're going to solve for c. You're going to write it as a trinomial, and then you're going to factor it to a binomial squared. Pause now, because I'm going to show the answer. Alright, c is 400, and then your binomial squared would be x plus 20 squared. Okay, flip it on up. Concept number 3 here. Complete the square when a equals 1. Alright, so just to start, if a is 1, it's a good thing. It's going to make things easier for us. We have to make a 1 no matter what. Even if a is not 1, we would have to make it 1. But in these ones, you're given a is 1. So I don't need to worry about that step. What I'm going to do is get ax squared plus bx on one side and kind of move my c over if it's not a perfect square. And in this case, again, it's not a perfect square. Therefore, I'm going to move it on over to the other side by subtracting 7 to both sides. Gives me x squared minus 10x plus, and I'm just going to put a blank there to complete my square, equals negative 7 plus blank. Because if I add this b divided by 2 squared to this side, I have to add it to the other side to keep it balanced and equal. Right? So, let's take that b divided by 2 and square it. Okay, so b divided by 2 is really, b is 10, or negative 10, divided by 2, which is negative 5 squared. Is 25. So I'm going to add 25 to both sides of the equation. Alright, on my left-hand side, I now have a perfect trinomial square. Take the square root of x, take that minus sign with the negative 10, take the square root of 25, which is 5. If I multiply them together, I get negative 5x. If I double it, I get negative 10x. It is perfect. Then on the other side, I just took 25 minus 7, and that is 18. The next step I want to do is solve by taking the square root of both sides. Alright, when I do that, I get the quantity of x minus 5 equals positive and negative. Well, just real quick, maybe I'll do this, but I'd break it to the square root of 9 times the square root of 2. Square root of 9 is 3, right? So I'd simplify as 3 root 2. You must always simplify any perfect squares. You have to take out a radical. Then the last step would just be to add 5 to both sides. And if we're not working with calculators, then we could just leave it in this answer right here. X equals 5 plus or minus 3 root 2. And that would be SRF form, simplest radical form, which generally is what I leave it to. Sometimes you are going to be asked to put in a calculator and write it as a decimal, which again you have 2 separate answers. That's the 5 plus 3 root 2, and then another 5 minus 3 root 2. But this answer is totally acceptable. But watch for the directions, what it's asking. Alright, go ahead and give number 6 a try. I'm going to go ahead and show the answer here, but pause it for now, give it your best go, and then refer back to it to check your work. Here you go. Your answer is x equals 9 plus or minus 2 root 19. There's all the work there. Pause it and take a look. I am going to go on to concept number 4, and that is completing the square when a is not 1. Okay, So if a is not 1, like we said, we have to make it 1 with these, like completing the square, or solving by completing the square. So what I'm going to do to make it 1 is just divide by whatever it is to each and every term. And if I divide by 3 to everything, 3 divided by 3 is 1, and I get 1x squared, or just x squared. 12x divided by 3 is 4x. 15 divided by 3 is 5, and 0 divided by 3 is 0. And now I've made my a term 1. Is 5 a perfect square? Nope, so I just go back to moving it on over to the other side, giving me x squared plus 4x plus blank, whatever I need to complete the square, equals negative 5 plus blank, whatever I need to complete the square. Alright, so what am I using to complete the square? b over 2 squared. My b term is 4, so I have 4 over 2 squared, which equals 2 squared, which is 4. I'm going to add 4 to both sides. Alright. Perfect trinomial square right there. Take my square root of x squared, and that's x, square root of 4, which is 2. Take that plus sign right there. If I multiply them together, I get 2x. If I double it, is it that middle term 4x? Totally. Alright, on the other side, negative 5 and 4 is negative 1. Next, I'm going to take the square root to both sides of the equation to solve for x. What am I left with? X plus 2 equals positive and negative. Well, what's the square of negative 1? I. We no longer are going to be writing no real numbers, right? We're going to use the imaginary number. Alright, so I'm going to go over here and complete this problem. So I have x plus 2 equals positive and negative I. All I have to do is subtract 2 to both sides. X equals negative 2 plus or minus I. And there is my answer. Just a real quick reminder, your real part always comes first. Your imaginary part would come second. Okay, that's how we write complex numbers. Alright. Take a look there again. And try number 8 all by yourself. Get rid of that a term, solve for x, and then write your complex number, real, and then imaginary. I'm going to go ahead and show you the answer there, so go ahead and pause. Okay. There we go. Number 8 is there. X equals 5 plus or minus I root 5. And I'm going to go ahead and just pause this video and start a new one for the last page.